A very good morning to one and all present here. It is my immense pleasure to welcome you all for the 35th Generic Talk Series on Opportunities in Energy Transition by Dr. Vigna Kumaran Ramachandaramurthy, sir, Deputy Vice Chancellor, University Tenaga, National, Malaysia. The purpose of this generic talk series is to provide a structured platform for intellectual enrichment beyond the prescribed curriculum. It is designed to expose the audience diverse perspectives, contemporary developments, and real world insights across various domains, thereby encouraging critical thinking, informed discussion, and lifelong learning. Welcoming marks the formal beginning of the program by expressing respect, gratitude, and setting a positive tone for the talk series. I now request our beloved head of the department, Dr. Y. Suki ma'am, to deliver the welcome address.
Good morning to one and all. It gives me immense pleasure to extend a warm welcome to everyone who have joined for the Generic Talk Series 35. Our management has always been committed to provide a strong industry exposure and real-world perspectives to our students, complementing their academic learning. The Generic Talk Series was initiated exclusively for the benefit of students. This distinguished series serves as a common platform that brings together eminent industry leaders, renowned experts, and global professionals, enabling our students to gain valuable insights beyond the boundaries of the classroom. On behalf of the management, principal, faculty members, students, and parents, I am deeply honored to extend a cordial welcome to our esteemed chief guest, Dr. Vigna Kumaran Ramachandaramurthy, Deputy Vice Chancellor, Research and Innovation, University Tenaga, Nasional, Malaysia. We are privileged to have Dr. Vigna Kumaran Ramachandaramurthy today to deliver the lecture for this generic talk series on the topic Opportunities in Energy Transition. Thank you, sir, for graciously accepting our invitation and for being the resource person for today's session. We are fortunate to have Dr. Vigna Kumaran Ramachandaramurthy to share his vast knowledge and valuable insights in the field of energy transition. I encourage all the participants to engage in this session by listening and posting questions through YouTube channel. Once again, on behalf of the management, principal, faculty members, students, and parents, and on my own behalf, I warmly welcome Dr. Vigna Kumaran Ramachandaramurthy to this session on Generic Talk Series. I also take this opportunity to welcome our faculty members who play a vital role in organizing and supporting all our academic and co-curricular activities in the department. Let us last but not the least, I warmly welcome our students and their parents for joining us today and for contributing to the success of this generic talk series. Thank you all for your participation. Thank you, one and all.
Thank you, ma'am. I now request Dr. M. Vimala, Assistant Professor of our department, to give an introduction about our distinguished chief guest.
Good morning, good afternoon, everyone. It's my great pleasure to introduce Dr. Vigna Kumaran Ramachandaramurthy, sir, a distinguished academician, researcher, and leader in the field of sustainable energy and power engineering. Professor Vigna Kumaran Ramachandaramurthy completed his bachelor's degree and PhD at the University of Manchester Institute of Science and Technology in the year 1998 and 2001, respectively. He then joined the Malaysian largest electric utility, Tenaga Nasional, Berhad, and served as an electrical engineer. He then moved to University Tenaga Nasional and became a full-time professor in the year 2014. Presently, our distinguished speaker is the Deputy Vice Chancellor, Research and Innovation at University Tenaga Nasional. He is also the Chair Professor for Smart Utility for Tenaga National Berhad Distribution Network and Honorary Professor at the University of Nottingham, Ningbo, China. His strong academic foundation has enabled him to develop deep expertise in the power system analysis, renewable energy integration, and emerging sustainable technologies, particularly electric vehicles and smart grids. Over the years, our distinguished speaker has established an outstanding research career focused on solving real world energy challenges. His work spans critical areas such as renewable energy integration into power networks, electric vehicle technologies, vehicle to grid system, energy storage, smart grid architectures, and grid stability and resilience. These research areas are central to the global transition toward low carbon and sustainable energy systems. A highly prolific and internationally recognized researcher has authored and co-authored numerous high-impact journal articles, conference papers, and review publications that are widely cited across the global research community. His comprehensive review papers on electric vehicles, covering charging infrastructure, grid integration, control strategies, and future prospects, are regarded as authoritative references for researchers, industry professionals, and policymakers. The topic of today's session, Sustainability in Action through the Use of Electric Vehicles, perfectly reflects Chief Guest Professor Vigna's academic journey and professional mission. We are truly honored to have Dr. Vigna Kumaran Ramachandaramurthy sir with us for the generic talk series to share his knowledge, experience, and vision with us today. Welcome, sir.
Thank you, ma'am. Sir, I now request our distinguished chief guest, sir, to take over the session.
Okay, thank you, madam. Okay, so first of all, it's an honor to present to the audience in India. I will go straight to the point. The topic for today is on the opportunities in energy transition. So the narrative that I'm going to put forward is on the research initiatives and opportunities, and I'm also going to link those opportunities to the need of the industries. You see, this approach is important because in my many years of doing research, I realized that at times research can be reinventing the same wheel. That's some people will reinvent the same wheel because of lack of data. Some people would do something which may not be relevant or it is not problem solving. Research could be undertaken and it has got no links to the need of the society. So in my humble opinion, I guess when we look for opportunities, it is good to have a problem statement in mind, which the society needs, and accordingly, you solve that problem statement. I think if we can do research in that manner, it would be very useful for the community and all of us. Okay, so what I'm going to share with you today is a buzzword called energy transition. Next slide, please. But before we even move into any energy transition, I guess we should understand what is energy transition. In this era when we have got a lot of climate-related issues, ice melting, sea levels coming up, flood all over the world, including in Malaysia. Many places are seeing flood for the first time in Malaysia as well. So all this is because of climate change. And therefore, there is a need for us to look into how we can prevent the climate from becoming worse. And one of such direction is the energy transition, whereby we try to avoid fossil fuel-based generation and move into renewable energy-based generation. I guess that is basically the most common form of energy transition in the world now. So my topic today is going to touch on renewable energy. I will touch some parts of electric vehicle as well. And I will also share with you some of the latest technologies which is out there, which we should also focus on. And when we talk about research, it is not always technology. Obviously, technology drives us forward, but we should keep in mind that technology is only one portion of research. You can also have policy as another portion of research. You also have cost benefit analysis, the financial perspective, and there is also a need for social scientists to be part of the research ecosystem. So research to me is not just technology, but it includes the finance people, it includes social scientists and policymakers. Together, that ecosystem, which cuts across interdisciplinary, will be valuable for the industry and the country. Okay, can we go to the next slide, please? Okay, so to start off, I'm going to link energy transition and smart grid now. As I mentioned, energy transition is moving from fossil fuel to zero carbon based generation, such as renewable energy. And the most popular renewable energy that I'm sure you're aware of all over the world, including in India, is solar photovoltaics. Wind turbines are also very popular, and this is going to be the focus for today. But when you talk about transition, the transition cannot happen if the backbone, the electrical backbone, is not robust enough. Electrical backbone means the distribution line, the transmission system, all of them which takes the energy from one point to another must be able to support the large introduction of renewable energy, or else the entire ecosystem will fail. For example, you can look at what happened in California many years ago, the dark curve issue. Or recently in Europe, there was a collapse in the network. In Vietnam, there's a collapse in the network due to large integration of renewables as well, particularly solar. So as much as we do the transition or we move in that direction, we must make sure that the network is able to sustain itself. The network can be operated reliably. The people who are operating the network are also competent to a certain extent. So basically, the entire ecosystem, process, technology, people, all have to grow in tandem, or else we are going to have a practical issue in the industry. Okay, so that's pretty much my opinion, and hence the word smart grid, which I believe most of you would have come across, or you will definitely come across if you're in the electrical world. Smart grid is basically an electricity network that uses digital technology, sensors, and software to better have an equilibrium between generation and load. In the electrical network, we have got two key parameters, the generation or the supply, or the demand, which we call the load in power systems. When the generation and load are equal, everybody is happy. It's equilibrium. But if the generation is higher than the load, then what happens? The frequency goes up. If the load is higher than the generation, then the frequency tumbles. Okay, so this is the fundamental in electrical system. So to ensure there's an equilibrium between the generation and the load, basically we need the infrastructure or the grid to be smart, and hence the word smart grid, which is popularly used throughout the network. In the Malaysian perspective, we invest a lot in smart grid. You see, smart grid is not about having sensors and control. Smart grid also means visibility. If I am the electrical operator, can I see, can I have visibility right up to the low voltage network? Because when I have the visibility, I can actually solve a problem. And what makes it worse in the real world now, which could be a potential topic for research for you, is I have limited number of measurement. So how do I observe the entire network with limited number of measurements? That is where you have got pseudo measurement, state estimation coming in to give you the visibility of the network. Okay, so I do not want to go too deep into the technicalities today, but I guess it's sufficient to tell you what researchers are doing and what the industry wants, so that you can actually think about doing some research, or you can prepare yourself mentally to join the industry when you graduate. Okay, next slide, please. Okay, next, please. Okay, so I have basically coined the energy transition into 6 areas, but obviously you can have more. Okay, I'm not limiting it to 6, but in the context of today's audience, I'm just limiting it to 6. Okay, and the 6 that I would like to share with you today, number 1 is the virtual power plant. Okay, the name virtual means you have got interconnection of generating plants to a particular network. That's virtual power plant. Peer-to-peer is another interesting energy transition initiative which is coming up throughout the world. So what do we mean by peer-to-peer? Example, I have solar photovoltaic on my house rooftop. Before this, I used to buy electricity from the company that sells electricity. But once I have solar on my rooftop, now I'm not a consumer anymore. I'm now a prosumer. I can actually start selling electricity or energy from my house, and therefore I'm now an independent power producer in a smaller scale. Okay, so that interaction between different prosumers is basically peer-to-peer. Okay, the other key technology to enable energy transition now is energy storage. I will go into details later. We started off with lead acid many years ago, and then lithium is now becoming, well, it's already popular. And from lithium-based energy storage, people are moving towards redox flow, sulfur-based, etc., etc. This is one area which is going to rock or control the energy industry in the years to come. It is energy storage. So it is one area that I think researchers should heavily invest their time in terms of application, in terms of sizing, etc. The fourth key area when it comes to energy transition is microgrid. Microgrid means it is a smaller version of a grid, and that's why we call it microgrid. And since it is a microgrid, the expectation from a microgrid is it is a self-sustaining grid. That means whatever happens to the electrical network, the microgrid will continue to operate without failure. Okay? What happens now in the real world, including in India, if I believe it's true, is whenever you lose the main grid, everything shuts down, including the solar photovoltaic plant. Everything shuts down because we do not allow a concept called islanding. Islanding means the network splits into small pockets of island and it continues to operate. The reason many people do not allow islanding in many parts of the world, including in Malaysia at the moment, is because when we have got our safety personnel to go and repair, they may not be aware there is a live system running at the background. which can be very detrimental and can be fatal as well. And therefore, we do not allow islands at the moment. However, as we grow, we also need to think about the way we do things. And hence, microgrid is basically a smaller version of a grid, which is self-sustaining and which will not be interrupted by whatever happens in the main grid. Okay, so that is microgrid. The last two areas which I will touch on in a short while is renewable energy. I think all of you know renewable energy. You have got solar photovoltaics, you have got wind turbines, you have got ocean thermal energy, you have got tidal wave, you have got biomass, you have got biogas, you also have hydro. They are all part of renewable energy. And if you like to extend this discussion to sustainable energy, then you also have got nuclear energy in the form of small medium reactors, which is now becoming popular. And it will one day be supporting, or it would be next to renewable energy. And so that's one area to look out, which is the nuclear energy. The last area that I will touch on today is electric vehicle. And I've been to India many times, and I've seen the two-wheelers, electric vehicle, the four-wheelers. It is a game changer. However, for it to be a game changer, there are certain ticks that you need to do. For example, is the petrol price low enough, or is it high enough? Number two, the battery lifespan of electric vehicles, etc., etc. Okay, so this is basically how I would address energy transition. Okay, let's go into the details of all the 6 areas now. Next slide, please, madam. Right, next, please. Okay, what I'm going to share is just an overview. I'm not going to go into the details today, so that we don't sound very technical. But what I would like to share with you are some of the best practices and the way forward when it comes to renewable energy. So the most common one now is solar, at least for us, because we happen to be in the equator or close to the equator. So solar photovoltaics is what we are driving at the moment. And in India, I've seen even in deserts, you have got a gigawatt scale of solar photovoltaics, etc. I guess that's excellent. Okay, but when you introduce too much of solar photovoltaic, which runs on power electronics, you end up with a loss in inertia in the power systems. Okay, so I don't worry if you do not know what inertia is. Inertia is basically the mass. Whenever a machine is rotating, you basically have got a mass which is rotating. So whenever there is a fault or some incident happening, this rotation will not stop immediately. It will continue to rotate and eventually slow down and stop or stall. That is inertia in the layman's term. Okay, so when you have a lot of solar photovoltaics in the electrical system, the issue would be there will be a compromise in terms of the system inertia. So straight forward problem statement or research topic would be, in Tamil Nadu, for example, how much of solar photovoltaics in terms of percentage of generation do we need to install before we compromise on the system inertia of Tamil Nadu? Okay, straight away there is a problem statement, there is a research topic. Okay, beyond what percentage of solar in whole India, for example, will we and do we would affect the inertia of the whole of India? Okay, right. Question number 2: how will the load profile in India look like 10 years ago, today, and 10 years from now? How will the load profile of the Tamil Nadu load or the Indian country's load will look like? And what are going to be the potential problems, and how are you going to solve it? This is where I would like to introduce you to a very interesting topic called the Californian duck curve. Californian duck curve basically means the evening or night load is going to be high and the daytime load is going to be low. Why? Because you've got a lot of renewables, and therefore the daytime load is going to be very low and the night load is going to be very high. That is popularly known as the Californian duck curve, because this incident was first spotted in California. And that has got an impact on how the local network is going to operate. So what will the utility engineers do in Tamil Nadu or India? What are the researchers going to do to solve this problem, which will definitely happen maybe 5 or 10 years from now? What are you going to do? So that itself is an opportunity for research. So research is all about anticipating the future and solving that problem rather than solving what was solved 20 years ago. So I guess since a lot of the audience are students, it's good to start thinking in that direction so that the research could be more meaningful. So that's a humble request. So when it comes to solar related best practices, people are now moving towards floating solar. That means you put the solar panels offshore, on the sea itself. And that's happening. Some people are putting solar on lakes. Okay. Why do they do that? Because the cooling effect of the water can actually enhance the efficiency of solar photovoltaics. So this is one direction of research or industrial practice. Solar cell technology, this is a gold mine. Basically, it means, when you looked at the efficiency of solar technology in 2010, it was about 20%, 18 to 20%. Now, if you look at the efficiency of conversion of solar cell, people have moved from monocrystalline to polycrystalline to thin film to perovskite to etc., etc. We are looking at efficiency of 25 to 30% easily across the board. And of course, some manufacturers have also claimed to have efficiency of more than 30%. Okay. So this is where it is a golden opportunity for you, particularly those working on the manufacturing of materials perspective. What is the best recipe for solar cell to generate the highest efficiency of conversion of radiance to energy? If you can find a very high level or high percentage of efficiency, I will say that you are an instant millionaire. Okay, so this is an opportunity for those in the material science area, and of course, electrical and power electronics as well. And then you've got some lesser versions like solar heating technologies, recycling plant. Typically, the solar plants can last for more than 10, 15 years. Electric vehicle batteries can last typically 8 years. Let's not argue on the number of years, but roughly. So what happens at the end of those life cycle? What do you do with the batteries? What do you do with the solar panel? That is another area or opportunity for you as well. Okay. There's another point there, which is on aggregated solar PV panel. Aggregated panel means we are controlling the output from the panel in such a way that it maintains the system reliability and stability. Okay, right. Okay, but having said that, renewable is not all about solar. You have got biomass, you have got wind, you have got hydro. Okay, and I've seen in India, for example, when I moved towards I think the western side, or if I go to Tirupati, I can see wind turbines. Okay, in 2010, we actually put up wind turbines in Sri Lanka. In 2010, the rating of wind turbines, offshore wind turbines or onshore, was about 1 to 2 megawatts. Now, the wind turbines are going beyond 5 megawatts per single wind turbine. You see, this is how the technology have grown. Those days, we used to have variable speed. Now people have moved into permanent magnet, etc., etc. So technologies are moving, and therefore research should also move in that direction. If you look at the bottom of the slide, I'm talking about technology, but let us be clear that no research is complete without covering policy. No research is complete without looking at the social impact. No research is complete without looking at the financial perspective. Okay, so research in any area should cover all of this. And my suggestion is this is where interdisciplinary research between departments will come in, so that every research will cover different perspective. There could be a department that looks into policy, and from that research, you provide a white paper or a policy paper to the government of Tamil Nadu, for example. So this is, so I guess when we do research, we need to think slightly on a broader sense, and not confine ourselves to technology as well. Next slide, please. Okay, electric vehicle, a very popular. Okay, maybe I'll take the questions at the end if you don't mind. Okay, next slide, please. Or okay, next, please. On electric vehicle. Okay, this is probably a very popular topic around the world. Electric vehicle, as compared to combustion engine. And it is becoming popular because there is a need to avoid, according to some agenda, to avoid petrol or diesel, which basically has an impact on climate change. Yeah. So people are moving towards using non-renewable based generation. So electric vehicle is here to stay, but keep in mind that there's also hydrogen-based vehicles coming in. So my question is, from the research perspective, is EV going to stay for the next 10, 20 years? Or are we going to see hydrogen cars coming in to replace EV cars? Okay. And what is the strength and weakness of EV as opposed to hydrogen car? Okay. So these are interesting questions that researchers would actually focus on them. So looking at best practices in EV, when you talk about EV, a lot of you think it's the car. To be honest, it's not. The car is quite straightforward. It's a normal car with obviously the chassis. It will have its internal transmission system. It will have the battery management system. It will have the driver, and it will have the battery as well, as opposed to the combustion engine. So it's a very simple system in the EV car. It is not rocket science. But if you look at the entire end-to-end value chain of the electric vehicle, there are many perspectives to it. One perspective, at the point where you charge the car. So it is basically the interconnection to the grid. What is the impact of charging the car on the grid in Tamil Nadu? How does the Tamil Nadu grid going to react when you have got hundreds and thousands of people charging their vehicles at night or daytime? Is there going to be any spots which is overloaded in the electrical system? So I'm just throwing in ideas so that students can think about, you can have a broader perspective of electric vehicle. Because the tendency for students, when you do electric vehicle research, is to use power electronics and come out with an EV charger. But to be honest with you, EV charger was done more than 10, 15 years ago. So what is it that you're trying to do now, which is different? Okay. There's also many people, and I know personally some very good friends who are working on wireless EV charger with high efficiency as well. That is the way forward. That's excellent research, etc. However, that is only focusing on the vehicle and the charger. There are also other perspectives to it. The interconnection to the grid is very important. When you charge the car, there's going to be billing system and payment system. There has to be apps and research in terms of how you do the billing. When you have got mass amount of EV charging, the impact on the load profile of the entire country is going to change. So how does the impact look like in 10 years down the road, in 20 years down the road, in 50 years down the road? How does the load of India, or Tamil Nadu in particular, will look like 10 years from today, with a lot of EV charging coming in, with a lot of renewables coming in? You see? So the daytime load is going to go lower. Very often, the EV charging may take place at home at night because you go home and you charge your car. So the night load is going to go up, the day load is going to go down. And that is a typical disaster situation in the electrical network. Okay. So as a researcher, what is your solution? What are you going to do? How are you going to address the problem and work with the local distribution licensee or the network operator in your area? Okay. So this is where the collaboration between the academia and the industry needs to happen. If it doesn't happen, what we'll do, you keep working on charger, okay? The industry or the network operator in Tamil Nadu or whole of India have got a big problem to solve, and there is no link between the two, okay? So my advice is, it may not be easy, I know, but to work with the local electricity corporation to get the data and to do forecasting or projection of the load demand in the years to come. And then work with them in terms of coming out with solutions. You know, that way, research will be very focused on solving a problem rather than doing research for the sake of doing research. Okay, right. So let me go through the details. So as I said, the electric vehicle value chain is not only about the battery in the car. You have the charger, you have the billing system and payment apps, you have the battery. Nowadays, the electric vehicle car batteries can take you up to 1,000 kilometers on a single full charge. Okay, and that is how the battery for EV has grown over the years as well. Okay, so some of the research elements that I picked up from observation. Number one is planning and operation of the EV charger infrastructure. Okay, something that the charge point operator or the electric vehicle operator needs to look into. Number two, sizing and allocation of charging station for EV network development. Very interesting. For example, I live in a particular area within Chennai, for example. The charge point operator or the EV installer would like to put up a charging station. It is not as easy as putting a charging station, because when you put a charging station, particularly the fast charger, which charges your car in about 5, 10, 15 minutes, the amount of power that it's going to consume to charge the battery is going to be very high. It could be in the range of 100 kilowatts to 200 kilowatts. Okay, that is one single nozzle or one single gun. If you have got many in that area, you are going to end up overloading the electrical network in that area, causing a lot of problems. Your cable is going to be overloaded. Your transformer is going to be saturated. So one leads to another. So sizing and allocation very often is underestimated by researchers. Maybe they are not aware of such a problem. So the design of the network, the sizing of the charging station, all have to work in tandem based on the local load. Okay, that is another area for research. System reinforcement for massive EV adoption. I can link best practice 3 and 4 together. For example, I want to charge the bus terminal. Let's say in Chennai, all the buses are now becoming EV buses, and they've got obviously huge batteries. And imagine charging many buses at the same time, and imagine the impact that it's going to have on the network. Okay, so you need to look into that. You can extend the study to include power quality as well. Are there going to be a lot of harmonics in the system? When you charge the batteries, the voltage is going to drop because of overloading. Is the voltage going to drop significantly low enough that it disrupts all the industry nearby? Okay, so that is basically research from the power quality perspective. Okay, next slide, please, so that I'll have enough time for the questions. Okay, electric bus charging depot, I've just covered. Billing system, how do you bill people who wants to use the EV charger? What kind of business model should the charge point operator utilize? What would be the charging tariff that would be beneficial to both the operator of the station and the consumer? So where is the middle point in terms of EV tariff? Okay, so these are very interesting questions that needs to be answered. Item 7, which is TOU. TOU stands for time of use. So one option in many countries is to introduce a higher tariff at night and lower tariff in the daytime to shift the load from night to daytime. So some countries are also exploring, including Malaysia, what if we change the tariff, night tariff and day tariff, so that we do not have the peak at night and TRA in the daytime? What do we do? Okay. Next slide, please. I think I'm going to address one of the questions that was brought in just now. V2G. You see, the world is changing. To me, an electric vehicle which runs on battery is a mobile battery. It is a battery which is moving around. So technically, we have got a mobile generator in the electrical system. And the question is, how do we use this? And this is where vehicle-to-grid technology comes in. Vehicle-to-grid technology means I connect my car anywhere that needs support, and I start discharging power from the car to support the grid. Whether that is detrimental to the car or the battery, I guess that's a different issue that needs to be addressed. But the concept of having a mobile generator is basically V2G. Okay, battery swapping. It's another very interesting industry that is taking shape. It is now very popular in China. I'm not too sure whether in Tamil Nadu you have battery swapping already. I'm quite sure you have. Basically, I drive to the battery swapping station. In 1 to 2 minutes, I remove the battery, I put a new battery, and the car can run around. Okay, that is battery swapping. And obviously, if you want to think a bit ahead, you can think about blockchain as well. Blockchain in battery swapping means I keep a record of the number of times the battery has been charged, the battery serial number, etc., etc. Is it? So research can always be expanded as long as you understand what the industry needs. Okay, next, please. How much time I have to the organizer, Dr. Sugi? How much time I have, madam?
In
15, 20
5 to 10 minutes, you
Oh,
can
5 to
take
10
some.
minutes. Oh, very short.
Mm.
Okay, okay. Right. Okay. The next is VANET. VANET is basically communication system where you can actually have communication between two vehicles. And the beauty of this communication is the vehicle to vehicle information sharing can tell you the number of cars that are queuing up in a particular charging station, how many cars are queuing up, and how long does it take for you uh, to go and charge your car. So this is Bennett communication research, which is also becoming popular, also in India. There was a question, I guess, just now in the chat box on wireless EV charging. Yes, wireless EV charging is there. In fact, I've seen working prototype of wireless EV charging in Tamil Nadu. You can check the place as well. They have static wireless charging. That means the car is static and you can charge your battery, which is right at the bottom of the vehicle. Or you can also have dynamic wireless charging. That means the car is moving along the rail, and while it is moving, there's also charging taking place. So wireless EV charging is the way forward, and it is already there in some parts of the world as a pilot. Okay, it is there in Korea, it is there in Holland. Why go so far? It is there in Tamil Nadu, in one of the labs in Tamil Nadu, in Chennai itself. Okay, battery as secondary life. Very interesting question. What do we do with the EV batteries? They last for 8 years. After 8 years, what do we do? Okay, so you can think about those areas. Next, please. Okay, next, please. Okay, energy storage, as I said, is the key for research and energy transition. This is one technology which is going to shake or hold the renewable energy industry. Okay, and you can use it for many purposes. I don't want to go into details because I think we can talk about an hour at least on this topic. The batteries can be used for load leveling, that means reducing the load. It can be used for frequency regulation. It can be used for power quality improvement. It can be used to support renewable energy, etc., etc. Okay. One, in terms of research, you can look into sizing. You can work with the industry to look into new materials for energy storage. You can look into supercapacitor to support energy storage, because there is a fundamental difference between storage and capacitor. Capacitor, high power, low energy. Storage has got higher energy, and hence the need for supercapacitor, which basically has got the strength of both storage and capacitor. Okay, next, please. Microgrid, as I mentioned just now, this is how the world is moving towards, including in Malaysia. We are now having housing areas to behave like a microgrid. So we do not need the big grid to control everything. Everything is controlled at a micro level. Everybody takes care of their own self, and therefore it reduces the tension higher up in the hierarchy. Okay, that's microgrid in a nutshell. Next, please. Peer-to-peer is basically everybody becoming a prosumer rather than being a consumer, and how the interaction between all the prosumers are taking place. So straight away, the opportunity is there a trading engine for you where you can buy and sell energy? That itself, a lot of people want. It's a huge opportunity. A trading platform where every country can buy and sell electricity or energy from the house level to a larger version. So that is peer-to-peer. Next, please. And on peer-to-peer, I've seen apps or engines that works on, AI platform that works on heuristic method, etc. Okay, you can look into that as well. Virtual power plant, it is basically generating plants connected in different parts of the country, but all connected and controlled virtually. That's a virtual power plant. Is there anything else next? Okay, but having said all this, I've got 3 or 4 more slides only. All this needs an enabler. Enabler means technology or expertise to help. And the key here is data analytics. Although I mentioned data analytics, I think obviously without saying it goes with machine learning, it goes with artificial intelligence, all of them put together. So data analytics is the game changer. We have got a huge amount of data all over. The utility have got data. The academias have got data. The question is, what do we do with the data? The data should be used to improve visibility. The data should be used to improve control. The data should be used to improve efficiency. So from the research perspective, what are you doing with the data? Okay, that's something to think of. Next, please. Advanced metering infrastructure. This is another game changer in smart grid, where you now have the traditional induction meter replaced by smart meters. When you replace smart meters in every house in the country, you basically have got data of all the houses in the country. And imagine having hundreds and millions, millions of data from different smart meters. Imagine the visibility that you will have of the electrical network. Okay, so advanced metering infrastructure is another game changer. A lot of big money is being put in. A lot of research is needed in this area. If you can link AI to the data, you will change the world. Okay, this is another key area for you. Next, please. I think it's my last 2 slides. This is something that I would like to share. A few countries are now moving towards distributed energy resource management system. In other words, it is a management system that controls and links electric vehicle, renewable energy, energy storage, all on a single platform without human intervention. So the challenge in front of you now is develop a platform that can integrate all the load, that can integrate all the renewable energy that is visible to you, and come out with a control strategy so that your platform manages the electrical network. If you can do this, I wouldn't say you're a millionaire, I think you're a billionaire. Large companies like a few large companies needs expertise in this area. So if you are good in power systems control, AI, machine learning, data analytics, look into this as well. Okay, next. Okay, this is another advanced distribution management system, similar to DERMS earlier, that gets a lot of data and it will be able to operate the network seamlessly. Okay, and whatever I've showed in the last few slides are basically areas that huge potential in the industry. If you can develop some apps or modules, even a small app, you can join the big boys of the industry. And the big boys I'm referring to are people, like Schneider, maybe Alstom, maybe Siemens, depends on the skills that they are looking for as well. But this will take you to the international platform. Okay, right. I guess with that, madam, I'm done. So what do we do now? Maybe I can look at the questions. Can we?
Yes, sir.
Yes, sir. Yes.
Okay,
Thank you, sir. Thank you for given detailed information about energy transition. Some of the questions are posted in the chat box. Are you able to see, sir?
Okay, yes. Okay, let me try the first one. What skills will be most in demand? Okay, very good question. When I started electrical engineering 20, 30 years ago, we learned electrical engineering only. Now, the electrical engineer, in my perspective, must know AI, must know machine learning, must know data analytics, of course, must know electrical engineering as well. So I guess there's a shift in operation or the way an electrical engineer thinks. He should not be a typical traditional electrical engineer. he should move into AI, machine learning, and that is the skill that I guess not only electrical engineers, everybody must have. Okay, that's question number one. Which technologies are closest to commercial scale but still underappreciated by investors or policymakers? It's a very interesting question. In India, you've got hydrogen car. It is clean. Basically, you get the hydrogen from the what do you call the fuel cell operation of water, isn't it? So your source is water, and you get hydrogen, and you obviously get oxygen out of it. And the beauty is, it is cheap. It's water. Your source is water. The problem is it's expensive. So these are technologies which, as I mentioned earlier, can an electric vehicle car be changed into a hydrogen car in the years to come? If yes, you're going to run a car on water. And imagine the impact if you can make a car run on water. Imagine how cheap or how beneficial it's going to be to the community. So it's a challenge for, or maybe I throw this as a challenge to the students who are listening. Develop a car that runs on water. Okay, it's an interesting challenge for you. Number three, what advice would you give third year EEs, Triple E students to differentiate themselves during campus placement in the evolving fields of electric vehicle? What advice would you give? Okay, my advice, very interesting question. As a third year student, if I put myself in your shoe, when you first attach yourself to good companies, I think that's very important. I'm not sure whether it's possible, but attach yourself to international companies. Write to them. Write to all the top international companies. Tata Consulting is there. Alstom is there. Write Shell International is there. Write to the big boys and get yourself attached to the big boys. Number two, remember the industry doesn't only want people with technology strength. Gone are the days. When I interview somebody into a particular role in the industry, I also want to see whether you're able to communicate. Very, very important. Communication skills is important. Your ability to think, nobody knows everything, including me. But are you willing to learn, adapt, and move forward? Very important. Are you willing to drive yourself to learn or to seek more knowledge? So you see, it is not how good you are that matters anymore. It is not your, I mean, this is my opinion. It may be different than Madam Suki and everyone else. It is not your CGPA that matters to me if I'm the industry interviewer. I want to see you being able to talk. I want to see you being able to have the drive in you. And I want to see the element of you, being inquisitive and, you want to learn. To me, that is more important because the minute you have the ability to learn, you can do anything. Okay, so that is basically what I would do because all these areas to me, you see, let me be honest with you. What is a renewable energy? A solar, which is a DC source. Then you have got your DC-DC converter, you've got your inverter, and you've got a grid. Okay, that is solar. If you look at the battery, the same battery will have a DC-DC inverter and the grid. So a renewable energy to me is the same as energy storage. Both are DC sources, both has got power converters in between, and both has got a grid on the other end. So technically, it's the same system with a different name. Okay, when you can look at electric vehicle charging, it's the same thing. If you look at the motor drive, it's the same thing. So all of them have got a source, power electronics, which could be DC-DC, buck boost or inverter, and the grid. So everything in the world is the same. So there's nothing great about technology. You can definitely work on it, but work on your personal skill. That will be the tiebreaker whether you go far in life or not. Okay. Next question. Can somebody scroll down for me? Sorry, the views are my own views, and may not represent everybody's. Okay. From an industry placement perspective, technical skill and software tools should be okay. There's a lot of tools, to be honest. The popular ones nowadays are Python to help you link between various softwares. If you go into power systems planning, you have got a software called Silent, PSSE. These are very popular. Southeast Asia, Thailand, Malaysia use Silent. So if you're going to do power systems operation planning, Silent is very important. Python is very, very important, something that I would ask all of you to learn. Yeah, if you're going into operation, the last two slides which I shared, DERMS and ADMS, those are the new technologies in the world. Okay, next question. Utilities and EV companies often mention grid integration challenges. Excellent. What kind of real world projects or internships should students look for? Okay, so the question is grid integration challenges. So my first question is, what are the challenges? Number one, power quality, which is harmonics. Number two, there's going to be a drop in voltage because you are overloading the line with more current. Number three, you will have, you may have the transformer in the substation to be overloaded. Okay, so these are challenges. Real internship to improve. Knowledge of EV charging is important. That means knowledge of power electronics is important. Knowledge of the grid and impact on the grid is equally important because, as I mentioned earlier, EV charging is the entire value chain. And that value chain is grid impact, power electronics, billing, and payment, battery, and you can stretch the battery to battery management system, BMS, etc. Okay, so the entire lot is the value chain. So if you want to do well in this area, I suggest you should know the entire value chain. Okay. For students aiming to enter core electrical companies, how valuable is hands-on experience with EV charging, power credit? Oh, everything that you mentioned is very, very, very important. Especially now because the network in the whole world, not only in India, including Malaysia and the whole world, everything that you mentioned, EV charging system, power quality, grid connected, these are the real problem. And how do you solve it? If you look at my last two slides in my presentation, the ADMS and DERMS, they are the solution to this problem. So where we need help from the industry is, every country could be unique. The problems in Tamil Nadu can be different than the problem in Malaysia, for example, in Kuala Lumpur. So we need the local scientist or the local researcher to pinpoint what is the local problem that you have because the way your electricity network is structured, and how do I solve that problem by writing a small module in the aggregator platform. That's all you need to do. You don't need to develop the entire platform. You just need to find a problem and come out with a small script for that problem, and you will make it to the big boys. Very simple. One example, Tata Consulting, you take it to them, they will be very interested. Okay, can we wirelessly charge the EV? 100% can. In fact, there is a pilot near your place in Chennai. You can look for it. They have got static wireless EV charging. They also have got dynamic wireless EV charging. Look for Professor Bharati Raja. Okay, he's the man behind this. If it is possible, what are the current methods in use or possible methods proposed? Wireless charging is all about having a transmitter receiver and then having the battery as close as possible to charge. Okay, so the trick is in terms of developing the coil to transmit from the transmitter to the receiver. That is where the loss in efficiency takes place. So the trick to wireless charging is all about improving the coil design and improving the efficiency of charging. Okay, I guess I've answered all. Okay, right. Okay, madam, over to you.
Thank you, sir. Thank you for answering all the students' questions. Thank you, sir. Now I call upon Sabri ma'am to give the vote of thanks.
Thank you, ma'am. Respected Chief Guest, Head of the Department, faculty members, students and parents, on behalf of the organizing committee, it is my privilege to propose the vote of thanks. I express my heartfelt gratitude to our esteemed Chief Guest, Dr. Vigna Kumaran Ramachandaramurthy, sir, for graciously accepting our invitation and for sharing valuable insights through an enlightening and inspiring address. Your words have truly enriched our understanding and added greater value to this program. I extend my sincere thanks to our chairman, our vice chairman, and our beloved principal, sir, for their constant support, encouragement, and guidance in organizing the event. My heartfelt appreciation to all our faculty members for their dedicated efforts to make this event a great success. I also extend my thanks to all the students and their parents for their active participation in the event. Thank you, one and all.
Thank you.
Thank you,
and
sir.
I look forward to collaborating with your university, your college, and your students. Thank you for the opportunity.
Thank
Yes,
you,
Professor.
sir.
Sure,
Thank
sure.
you.
Thank you so
Thank
much.
you so much.